Welcome back to our channel again. This is Captain Sherry, and today we are going to discuss about center of flotation. What is the importance of center of flotation in stability? What is a hydrostatic draft? What is the relation of hydrostatic draft with the center of flotation? And if you look at your hydrostatic stability booklet of your ship, why everything is listed against the hydrostatic draft? What is the reason? Right? So these are the questions which we are going to find out today in this video. And if you look at your screen, the first thing which you see on your screen is seesaw. Now, there is a plank on a seesaw, and that plank is parallel to the ground, right? Right? Now, why it is parallel to the ground? There is only one reason, because X, this weight, will be equal to this weight. And it is also equally distributed from the center. So this is the center. It is equally distributed from the center on either side of the plank. And that is why the plank is horizontal to the surface or to the ground. Now, if I want to find out a height of each point, say A, B, C, D, and E, all the heights at every point on the plank will be same from the ground, right? So if I have height h, okay, from the ground, okay, to the plank, that height will be same for every point. Let it be at point A, B, C, D, or E, right? Okay. Now, if I shift the weight, okay, if you see the second figure, I have shifted the weight. So the weight has been shifted on a new location. So what is happening is I have shifted it from one side to the other side. So when we shift the weight from one side to the other side, it will get actually listed, or it will get heeled on one side, and that is what happens on a ship also, right? So now what is going to happen? The plank is now listed on one side or heeled on one side, okay? And now what is happening is the height is changed now. If you see A, B, C, D, E, okay, right? So if you see, height at A has been increased in comparison to the height which was there at A at the first figure, right? B is also increased, D is decreased, E is actually gone below the ground surface, touching the ground actually, right? Now, there is a point which is C, which has got the same height as the previous one, right? So height of point C remains same as when the plank was horizontal, okay? So if you see this height of a plank, okay, if I make this H, this is still the same. If I draw a line like this, if I just draw a line like this, right, and you will find that this is still the same, okay? So C is a point at a fulcrum which is actually having no effect of this listing, okay? No effect of listing, okay? So plank is listed on one side, but it has got the same height as the height which was before when the plank was horizontal. There is no difference at all, okay? And this point actually of a fulcrum, we can say that this point is your center of flotation for a ship. Understood or not? Okay, right? So this point C, if I think a plank is a ship, okay, now this is a point which is also known as center of flotation for a ship. We'll prove it, okay, to you once we go to the further figures. But just to make your base, okay, you need to just remember that center of flotation has absolutely no effect of a ship listing, okay, or get inclined on one side, or if it is trimming, Okay, so inclination also is longitudinal or transverse, right? There are two inclinations. One is your longitudinal inclination, which will be causing trim, and other will be transverse, which will be caused by either list, okay, or it might be caused by external factors like wind, etc. also, right? Okay, now let's go further ahead and see what is happening. Okay, if you see the figure now, and if you see these figures, now what is happening is, okay, you see this figure 1, and there is a ship which is there, okay, and figure 2 also. Now, figure 1, when I have put in a weight in the forward section, okay, and the weight is equally distributed among the ship, what is happening is, okay, the ship is on an even keel. If the ship is on even keel, what is going to happen is the height will be the same, and it will be not the height now. I will call it as the draft at each point will be the same from the keel. Understood or not? Okay, what is happening in figure 2? Now I have shifted the weight. Now this weight which was there in the forward section, I've shifted that weight in the aft section. Okay, so if you go to figure 2, the weight has come now in the aft section, which has made the vessel to trim. Right, now what is happening now? Now the draft at C is still the same, okay, but draft at different points, say A, B, D, and E, has been changed. Right, if you compare it to figure 1, look at this draft A. Okay, so draft A has been reduced, right? Draft B also has been reduced. D has been increased. E has been increased because of the trimming of the vessel. But if you compare draft C, which is this one, if you compare this height or say the draft, it is still the same. Okay, it is still the same. Now what I will do is I will take it as that, oh, this height is still the same. This height and this height is still the same. It has no effect of longitudinal inclination, that is trimming of the vessel. So now what will be my point? This point will be my center of flotation. I told you center of flotation has no effect of the inclination of a vessel. There is no effect on the center of flotation for inclination of vessel. Okay, let it be transverse inclination or let it be longitudinal inclination. Understood or not? Okay, so draft at center of flotation is not affected by a ship's inclination, same like the height of the plank in a seesaw at fulcrum. Understood or not? Right? Okay, now why we choose draft at center of flotation? We choose draft at center of flotation, which is also called as the hydrostatic draft, because of only one reason. This draft has no effect of longitudinal or transverse inclination of a ship. Right? So the calculations are easier. There is no correction to these calculations. We know that at the center of flotation, the draft, which is also called a hydrostatic draft, will be unaffected by longitudinal or transverse inclination. Right? Now, if somebody is asking you how to find out a center of flotation, you can just say it is a geometric center of a water plane area. Right? After so many experiments, scientists have found out this thing, that a geometric center of a water plane area is also known as your center of flotation. Right? Okay. Now, let's go further ahead. Now, what is a water plane area? Okay. So, say, for example, to just elaborate on this, okay, if to just elaborate on this, and if I want to say how to determine the water plane area. Okay, so this is a box shaped ship. Now, if I send somebody down, okay, say for example, the shape and size of a water plane area will depend on the form of a ship at different drafts, right? If I put in other words, water plane area of a ship may be different at different drafts. What is a water plane area? It is just the area bound by a ship hull or at the sea surface. So if I'm sending somebody, if I send somebody down over here, and if I tell that person that please draw a line among at the water surface, okay, at the boundary of a ship. So what this person is going to do? This person is going to draw a boundary on in here, in here, in here, go to the other side and make a boundary like this. Okay. So in go here, go here, go here, and okay. Or if I can say that if I lift this shape from the crane, or there is a portion of that ship which is still lying on the water, which I can say a stamp of the ship which is lying on the surface of water, that will qualify as the water plane area. Okay, in case of a box shape ship. Understood or not? Right? So what is happening here? In this case, what is happening is if I draw a water plane area, the water plane area will be this. This will be my water plane area. Now, this will be not affected by the draft of the vessel. Why? Because in case of a box shape vessel, okay, either my draft is this much or my draft is this much. If my draft is this much, okay, it will still the same, because the boundary which will be drawn against the uh, ship on the surface of water will be still the same. Okay, so water plane area will be still the same in case of a box shaped vessel. Okay, let it be the bigger draft D or let it be the smaller draft D, it will not change. Understood or not? Okay, now, but the ship is not a box shaped ship, isn't it? The ship has different shapes. Okay, ship has different shapes. So if I want to go ahead and look at this figure now. Okay, now look at this figure. Okay, in this triangle, okay, what is happening is if I tell the person please draw the boundary across the hull of a ship, and he starts making a boundary across the hull of a ship. Okay, if I am considering small d, which is a draft at where I've just drawn the water plane area, and if I compare it to the bigger draft, so look at this now, this breadth and this breadth is different, right? Correct? And as you are going up, okay, as you're going up, say for example, if I want to draw a water plane area somewhere here, okay, somewhere here, okay, at this draft, so what is going to happen? Okay, it will come like this. Okay, so obviously my area has increased. Okay, my area has actually increased. Okay, right? Right? So my water plane area is actually changing with the draft. Okay, in this draft, my water plane area is this much, only this much. But if I go further ahead, okay, and if I say, okay, at this particular draft, say over here, so what is going to happen is I need to draw a line like this. So obviously now, look at this triangle, this bigger triangle, okay, which I've drawn just now. Okay, so look at this triangle over here, and here. So there are two triangles, right? One is this triangle, right? And another is your this triangle, which is the bigger triangle. Okay, which is this one. Okay, right? Which is this triangle. So that triangle, which is in the green, is bigger than the yellow triangle. So now my water plane area will change with the draft. Understood or not? Okay, right? Right? So you need to define the water plane area of the vessel all the time. Okay, now look at this ship. What is the water plane area now in here? Okay, so if I want to derive the water plane area of this ship, it is very, very easy. Okay, you've guessed it right. It is going to be this one. Understood or not? Right? Okay, now once I take the geometric center of this water plane area, okay, that will be my center of flotation. That will be my center of flotation. Okay, so if I make, say this is a water plane area, okay, this is a water plane area over here, okay. So the geometric center of this water plane area, if it is lying over there, that will become my center of flotation. Right? Okay. Now, so what we've learned now, the hydrostatic draft is a draft at the center of flotation. It is not affected by longitudinal and transverse inclination. Okay, it is not affected by that. Okay, the factors which are affecting the hydrostatic draft of a ship is your displacement. Obviously, if it is a higher displacement or a lower displacement, what is the weight and the density of water? Because once you're going from the fresh water to say a salt water, okay, or salt water to a fresh water, right? Your draft will change, and draft will change the water plane area. Water plane area, if changes, your geometric center will change. If your geometric center will change, the center of flotation will also change. Okay, so after all the theory, what we've learned, now we will be deriving what is a hydrostatic draft. If you look at the figure, there is forward perpendicular, there is midship, and there is aft perpendicular, right? F is your center of flotation. What is the center of flotation? It is a geometric center of your water plane area, right? Okay, and what is a center of flotation? And center of flotation is also point where your hydrostatic draft lies, right? And if you remember that seesaw game, you will still be remembering that center of flotation will have no effect of the inclination of a vessel. Let it be longitudinal or transverse. Now, what is happening in this figure? The vessel is trimming. Okay, if the vessel is trimming, now it is a longitudinal inclination, and still center of flotation will have no effect of this inclination, neither the hydrostatic draft. Right? Okay, so what is happening now? We need to calculate a hydrostatic draft at that point. So what you need to know is, first of all, mean draft. What is the mean draft? Okay, that is the first step, finding out mean draft. Then just find out, okay, where is the center of flotation lying from the midship, how far it is from the midship, and then divide it by LBP. Okay, and you will get a correction, and then of course you will have to add that correction or subtract that correction again, depending on where the center of flotation is lying. Okay, you will be finding out the hydrostatic draft. Okay, so in this case, the center of flotation is about 2 meters from the midship. So this is the midship, and this is where the center of flotation is. So this distance, okay, this distance is basically your 2 meters. Okay, right? So I will say correction is equal to HF into trim divided by LBP, right? So what is HF? It is 2 meters. I have put in a value over there of 2 meters, and that is this value. Okay, and then what is the trim? So 10 minus 5 will get me the trim. So this is my trim divided by 100. Okay, and I will get 0.1 meter as a correction. Okay, now I will find out a mean draft. What is the mean draft? It is 7.5. 10 plus 15 divided by 2. So it will be 7.5. Okay, and the correction will be added. So my hydrostatic draft will be 7.6 meters. Right? Now, I just want to tell you one more thing, that why I have added this correction. If you see the water line over here, okay, so if you see the midship draft, okay, from the midship draft, okay, your center of flotation is lying 2 meter behind, okay, and if you see this water line here, the what the draft has got decreased, okay, and from here after it has got increased, okay, and that is why the vessel has trimmed, right? Okay, right? Understood? So now your hydrostatic draft will be 7.5 plus 0.1 meter. Okay, so it will give you 7.6 meter. Okay, now you can also look at your hydrostatic tables. Okay, what has been given to your ship. Okay, maybe HF is not available there, and what is available is your AF. Okay, which is the distance from aft perpendicular to the center of flotation. So this is A. Okay, so from there you can have this also. Okay, that is this distance. Okay, right? So if, say for example, my LBP was 100 meter, which is this one. Okay, it is 100 meter. Okay, so at midship it will be 50 meters, right? So this is 50 and this is 50 meters. So what will be my AF? Okay, so that is 2 meters. So if I subtract that, so 50 minus 2 will give me 48 meters. Right? So again, I can do the same drill. Okay, what I'm going to do now is the formula will be, correction will be AF multiply by trim divided by 100. What is that? 48 multiply by your trim, which is I think you got 5 meters, right? Your trim is 5 meters, right? So आपके trim जो है वो 5 meter है. Okay, so divided by 100, so it will be what? 240. Okay, divided by 100, which will be 2.4. Right? Now what you're going to do is, you have got this value of 2.4 meters. Now you know that your aft perpendicular is at a higher place. If you see the water line, if you see this is a midship, the draft has got increased. Now this value over here has more value, okay, than your draft at the center of flotation, which is hydrostatic draft. So what will happen now? What will happen now? If you have understood the concept at this level, okay, the draft is higher, okay, than this level, right? So you need to subtract that. Okay, so what is your aft draft? Okay, so you've got a draft of 10 meters. Okay, so 10 minus 2.4. Okay, so if you subtract 10 minus 2.4, okay, what you're going to get? 10 minus 2.4, it is going to be 7.6 meters. Okay, right? So that is also a way of finding the hydrostatic draft.